So up next, cropping systems and rotations. We've got Don Wysocki, Stephen Machado, who had an epic journey to get here, and glad to see that he's able to join the Zoom session. And then Nancy Powell from Progene, I believe. All right, well, if you'd like to introduce yourself, starting, I guess Don's already introduced himself for the earlier session. Stephen?
Hello, can you hear me?
Yep.
Okay, right. My name is Stephen Machado. I am a dryland systems agronomist based at the Pendleton station. My main focus is on trying to reduce fallow, intensify cropping systems, and diversify the crops grown in the systems around. And this is just to improve the sustainability of the cropping systems here by improving the soil health, as Mary indicated in her video, and in what we always say in many of our field days, when our presentations, the fallow system is depleting soil organic matter, and we think it might not be sustainable in the long run. So my main focus is in trying to improve the soil health, and particularly soil organic matter, and the sustainability of the cropping system. I was supposed to have posted a video on some work we've started on, some cover crop systems and alternative crop systems. We started this last fall, but I hadn't got the time to do it. I had been outside the country and got caught up in the lockdown in one of the countries. So I just came in a week ago. And so in the next few days, I'll post a video of the cover crop systems and alternative crop systems we're trying to put, we're working on, again, trying to improve the soil health of our wheat-based cropping systems in the Pacific Northwest. So with that, I'll just let Nancy introduce herself, and then we can take questions.
Good morning, everyone. This is Nancy Powell with Progene. I also have Kurt Braunwert, the owner of Progene, with me. So if you have questions for him, he's definitely available as well. And in addition to that, I'll just introduce myself and also Kurt, and let you know what exactly we're working on these days. I'm the pulse breeder for Progene. I've been with Progene for approximately 6 years. Currently, we have a winter pea trial down in Pendleton at the research station there. It's a yield trial. And in addition to that, we're working with Paul Carter on a liming trial. You may have seen the video that was taken last week, I believe it was. And if you'd like to ask any questions about that, I'd be happy to entertain those questions.
Maybe I can elaborate on the cropping systems study we're having right now. Actually, this is a collaboration with USDA, and both USDA scientists and Oregon State scientists based at the station are all collaborating. And we have two sites, one in Pendleton and one at the starvation farms at Chris Rost's farm. And so we have an alternative crop trial and a cover crop experiment at both sites. So with the alternative crops, we're trying to replace the fallow with an alternative crop. something which can bring both economic benefits to the farmer and also some soil benefits, soil health benefits. So our rotation will be like after winter wheat, we then have either a fall, an alternative crop, and then we go back to a fallow. So in this situation, we're reducing our fallow from one other year to one fallow year in 3 years. And we have decided on doing fall cover crops, spring cover crops, and summer cover crops. So the fall cover crops, they come in immediately after the wheat harvest, and then we would terminate them early in the spring. So we're talking of crops like winter pea and similar crops. And then we also have spring cover crops. Those would be like mustards, spring peas, and also then those will be planted in March and then maybe terminated in, not cover crops, I'm sorry, alternative crops. So they'll be planted in March and then terminated in, around July. And then if possible, if there's moisture, we could include a summer cover crop. Those would include those warm season crops. And then after that year, then we go into a fallow. So with the cover crop system, we also have similar setup, but then this one is still, we're trying to replace the part of the fallow and put in a cover crop system in that period. So after the winter wheat, we have a fall cover crop or a spring cover crop again, and then go back following year to winter wheat. So, and then from there, so we have got these individual crops for every category, and then we make mixtures of these cover crops based on the objectives of the experiment. For instance, if you are interested in increasing your nitrogen, then you have more leguminous plants in the mix. If you're interested in disease management, then you have more brassicas, mustards, crops which we know suppress diseases and nematodes. And then if you want to increase organic matter, you can also have more grassy species in the mix. So we're in the process right now of trying to figure out what crops to mix and how to grow them, trying to figure out how to manage disease weeds in such mixtures and when to terminate those cover crops. So this is just the beginning of a 5-year project, and we've got so many others, questions to answer in terms of these crops. One thing to bear in mind is it's going to be a little bit, challenging to grow these crops in our environment, given the precipitation we have. Yeah. Unlike the Midwest, where they have, summer rains, they can, do these cover crops and alternative crops systems really well. And that's why most of the information on cover crops is coming from the Midwest. Here we have a limited amount of rainfall, mostly in the winter. And as we go to the spring and summer, we lose the moisture. And so it's going to be a little bit challenging. And we'll see. It's an experiment. It's going to be challenging for the cover crops. For the alternative crops, it's a much better situation because if a chickpea crop can, it's got a good market price, farmers can easily grow that and get the money out of it, and then go into a fallow without actually really sacrificing on the yield. With the cover crops, we're just trying to improve the soil health. We're literally not getting anything that year when we do the cover cropping, but we expect those benefits to carry over to the next crop. So with that, we don't have much to say in terms of results, but maybe in the coming years we'll have more information for you.
So anyhow, pulse breeder with Progene. We're working on winter peas, spring peas. We're enjoying some really interesting research on different aspects of winter peas and spring peas. Kurt, would you like to add anything to that?
Well, basically, part of what we're looking at is how these varieties function within the marketplace. In other words, we've all studied a lot about how they function agronomically in the farm, which is important, and we're not forgetting that. That's really still an important component. But what we're looking for is ways to add value to all segments of the chain, including the farm. And one way to do that is to find unique, special characteristics within the varieties, which makes them uniquely valuable to the end user. And then we can bring that value back to the farm. And that's, Nancy's working real closely in that. In fact, we were just talking with a couple people earlier this morning about that and also how to measure that. Okay.
Don, you did a video on your canola peas cover crops. Can you speak on that for a minute or two?
Sure, Mary, thanks. We did a trial this year out of curiosity. I've been hearing quite a bit at some meetings about people growing peas and canola together. So this spring we planted a trial where we varied the amount of seed in different ratios. We started out with assuming that canola 100% stand was 14 live seeds per square foot, and a pea stand was 10 live seeds per square foot. So we planted those each in pure stand, and then we made the combinations of 2/3 pea, 2/3 canola, 2/3 canola, half pea, 2/3 canola, the third pea, and then we did the reverse, 2/3 pea, half canola, and 1/3 canola. And I had planned, at least one thought was I would show these at a traditional field day. This year, for whatever reason, I'm not sure I have the exact causal factors, but the brassicas, both canola and mustard, were extremely slow establishing and getting out of the ground. And maybe that's why we do experiments for several years. But when we first started this experiment, the peas came up, looked pretty good. And, part of the challenge is those two crops are seeded at different depths, so we kind of compromised. We did seed right next to our spring canola trial, and that was seeded a little bit shallower, and then we seeded the pea canola trial. But it was a full month before we had a stand of canola. Peas looked great, and I almost thought we had a crop failure on the canola because it was so slow establishing. But now that it's established, it's interesting. Maybe that's part of the synergy here is peas grow in part of the season and canola grows in another part of the season. In the video, we walked through the trials and you can see the different ratios, and the canola is starting to bloom, so it shows up.
They're concluded, but I was going to add that besides this experiment we're starting right now, we have done experiments with the Bryantac at the Moro station of this alternative crops for about 6 years. And the results we got were such that each time we had an alternative crop, we also reduced the wheat yields subsequent wheat yields were also reduced, almost in, let's say, 5 out of the 7 years. The only other 2 years where we had no significant difference between the wheat and the alternative crops was when we had some significant spring precipitation. But the situation was a little bit different at Pendleton. We had a 2-3 year study there of this cover crops, and we found that including a cover crop in the system did not significantly reduce the wheat yields. And these results confirm also the long-term results, long-term experiment results of the station, where the wheat following the peas yields the same, if not sometimes more than the wheat following the fallow at the Pendleton experiment station. Of course, it's a little bit different in a dry area like Morrow. So just to tell you what we might expect to find in the new experiment when we compare the starvation farms where the precipitation is close to 9 inches, Morrow is 11. So 9 inches is going to be a really extreme environment for that compared to the Pendleton experiment station. So those are just brief results of some of the work I've done on this subject.
Can I ask a question, Stephen?
Go ahead.
Okay, this is Kurt Brownward. And have you been finding, because obviously one of the keys with the cover crop is not depleting the soil moisture too much to hurt the wheat crop. Have you been finding some particular management or timing that allows the cover crop to provide some of the soil benefits but not reduce the soil moisture too much?
Yeah, good question. What I've been doing is just to terminate, the cover crop as soon as they make, sufficient biomass, but before they deplete moisture. So typically before they even go to flowering, then we terminate the cover crops. But it looks like this has been location specific, where we have more moisture, like at Pendleton, then the cover crop would do pretty well. But where we have less moisture, like in Morrow, then it's a bit challenging. But from the long-term plots there at Morrow, realize that we have one treatment which is continuous winter wheat. So it's not a cover crop as such, but we are having a crop every year, which almost simulates what we're doing with the cover crops. We found that when we did the continuous winter wheat, the first 6 years were just a disaster in terms of yield. Sometimes we would get about 16 bushels, 20 bushels. But then as we continue, with that system, just because we're adding residue every year, some organic matter every year, we started to see an increase in organic matter in that system, also an increase in soil moisture holding capacity, and then started to have better yields year after year after that. So I think when we look at low rainfall locations, I think it's a matter of persistence over some years to build up that organic matter, which improves the water holding capacity. And I think that might be the solution in the drier regions. But it's a long-term kind of objective, and I'm not sure farmers without any subsidy can pull it off for 6 years before they can start getting some meaningful benefits from the system.
Stephen, this is Drew Lyon. In the Great Plains, the only way I used to do drying cropping systems work, and the only way we could see cover crops working was not to really treat them as cover crops, to treat them more as a forage crop, so that you get some value out of the forage. People could manage that. Maybe if they want some cover crop benefits, they don't cut as much off as for forage as they do. But if to just grow it for cover crop with no economic return, direct economic return, plus the likely negative effect on the following wheat crop, it just didn't work. Whereas a forage, you could at least, you still might lose some value on your next wheat crop, but at least you gain some value in the forage. I don't know if you've looked at that as a possibility.
Yeah, that's a really great point, and I've seen other places where they're trying the forage angle, and I think that could be a workable solution. We have another experiment we were doing with NRCS again. It's cover crops. There were some few farmers that were interested in grazing some of that, but we haven't decided to go ahead with that. But that's certainly a good way to make it work. Thank you.
That grazing work's a lot more work, but it actually, you even save more money because then now you don't have to cut, bale, and haul. You just have to let the animals out. But it's not easy to do research that way.
Yes. Yeah.
Kurt, I'd like to ask Kurt a question. Do you have some good forage peas? I hear people talking about that with huge yields, or any other stuff, peas coming, or plants like that that you're finding decent markets for?
This is Kurt. There are some in use now. Where the winter forage pea that is actually a blend of two varieties. One's semi-leafless and one's normal leaf, icicle and keystone. And then in spring, there actually are people growing them specifically for straight peas for hay to go into the feedlots, because the feedlots one of feed rations with some higher protein stuff. And these varieties, Grant's our breeder on that, and these varieties are really designed for either dry land or irrigated. But in irrigated, they're a double crop. In the dry land, they're a rotational crop. And then they come off earlier, which allows for more moisture to be available for the fall wheat.
Kurt, this is Bill Schillinger. I also have and Nancy. I also have a question about winter pea, if I could, and it's regarding this Keystone variety that you have. And until last week, I wasn't even aware that you had this until I saw it in a grower's field, and I walked out into it, and it was like, oh my gosh, it was really so tall I couldn't even hardly walk through it. And so I contacted the grower, and he said he's growing these for seed for you folks. And I had all sorts of questions, but basically, what is the seed size? Is it a smooth coat or mottled? Is this something you could put in bulk bins in supermarkets, and or is it a true edible? Is I guess what I'm asking.
So yes, Keystone is available. Essentially, it's a banner type winter pea. So it's very similar to banner if you're familiar with that one. It has a little bit of a dimple. It's a green pea. It tends to be, as you saw in the field, very tall, semi-indeterminate, but it still stands pretty well, well enough to get the combine through. As far as seed size, since it is slightly indeterminate, there is a little bit of a variability in seed size towards the top of the plant. And we're essentially using it as a, how do you say that, forage, dual purpose type of pea. I don't remember the rest of your question, so if you want to elaborate on it, that'd be great.
I just have one last question. What about its winter hardiness in relationship to blaze?
Yeah, so in relation to blaze, it won't be nearly as winter tolerant as blaze, but it still does quite well on the Palouse, in regions down in Dayton, Walla Walla, the Lewiston area, those sorts of environments, it does quite well, including the Palouse.
The location near Ritzville is the first time it's been grown in that particular area. And that's because we started it in the warmer areas. And then, of course, anytime you do that, they like to push, find out what its limits are and push further north, and which has occurred. That's been grown in Rosalia and now for the first time in Ritzville. There's actually 4 varieties in use now, 2 yellows and 2 greens. And the last 2 years, between all the varieties, they've totaled about 12,000 acres. And that's stretched all the way from Pendleton to up in Waterville and Davenport. So they're finding their territory.
We have a question for Dawn. And what seems to be the best ratio of peas to canola is the question, Dawn.
I can answer.
Oh, sorry, I had mute on. Thanks, Mylan, for asking that question. And our observation have been, when this crop first came out of the ground, I thought none of the trials had enough canola in them. They all had too many peas. My observation now is, the canola is coming on better, and so somewhere around 2/3 of a pea planting and a half or a third of a pea, those are kind of looking the best now. Maybe at harvest, my mind will change again, because I think from this point on, the canola will probably be the stronger crop. But so I don't know if I can answer that, but my observations have changed over the year. Go ahead, Stephen. You were going to say something there.
Oh, that was unrelated to that. It's similar but unrelated. It was about when we did crop mixtures with wheat and peas. Because we are trying again, we didn't want to mess up with the fallow, so we decided we're going to put that pea crop together with the wheat crop, and then still maintain our fallow. So where we determined all these different rates of peas that won't affect the wheat yield, and we had found that three seeds per square meter, per square foot of peas was the adequate, was the optimum, and then while maintaining the normal sitting rate of wheat.
A question for Stephen and for Dawn. It sounds, well, obviously, Dawn, you're talking about companion cropping, and Stephen, you just alluded to that too. Are you finding, in your research, are you finding reasons to be interested and more interested in companion cropping?
Okay, I'll go first. I am particularly interested in companion cropping because of the so many benefits it brings in. For example, if you mix plant the wheat and the peas, or wheat and clover, you tend to get a lot of benefit from the companion crop. For instance, the clover or the pea would contribute nitrogen. There's literature which shows that the peas or the legume would contribute nitrogen to to the current crop and also to the subsequent crop through the nodules. And also because if you make sure, if you plan it, design it such that the compounding crop is between the wheat rows, then you reduce your weed population, or sometimes even eliminate it. There's one time we had a very good cover, spread of this clover at the station there. There was very little weeds coming through that mat. And then because the whole surface is covered by plants, most of the water going through is through evapotranspiration and not evaporation. So you're increasing water use efficiency at the same time. And then what would be desirable, and then again, the other component crop might attract insects. Like for instance, we had, attraction of some, other insects which are feeding on the aphids, which was on the wheat. So there's all those kind of situations that can happen. And again, if you are utilizing different crops with different rooting systems, you make use of the soil resources without much competition. So, and then I think the main thing is then what you do at harvest. With us, we were looking for a crop, and we tried some of your varieties like Windham, Spectre, and so forth. And then we found that this is very important when you choose the companion crop as to your needs. For instance, when we grew Spectre with the wheat, it was very aggressive, and then it almost like choked the wheat at the station. But if we grew Windham remained on the floor, doing all the stuff where the benefit, giving all those benefits I was talking about. And when we used clovers, dryland subterranean clovers, they just grew to the 1/3 of the wheat height. So we were able to cut our wheat without even cutting the clover. So yeah, I'm interested in more work like that. And then, looking at pea varieties or any other, companion crops which are compatible with the growth of the pea with the wheat crop.
My answer to that would be similar to what Stephen said, but the specific companion system we have with this peas and canola, some of the observations is that peas come on early, so that they're taking some advantage of some of that early growth. A pea is a more shallow water user, canola is a deeper water user, so you're maybe exploiting water from different levels. That could be a benefit. And Stevens also said that the thing about nitrogen, if peas are, for lack of a better word, leaking nitrogen in the system, and canola can take advantage of that, that would be great. And then there's got to be some advantage to having these two together for the microbiome that's there. And maybe if we continue this work, somebody like Kate Reardon could study that a little bit to understand what's going on below the ground with the microbiome. The survey that Deb put there, the one question that the last question in that is some of the challenges of growing these two particular crops together. And in my mind, the weed issue might be the biggest, but how to separate these after you harvest them, and the operation of planting a small seeded crop like canola with a crop like peas can be a challenge. So interesting that the group kind of split about 25% among these 4 different challenges.
I think that that's a really good point that you brought up, Don, on looking at the soil microbiome. And this work also feeds into the cover crop and alternative crop work that Stephen is working on collaboratively with us. So we are bringing in new faculty that will be arriving sometime in the next year, with a bioinformaticist, a crop physiologist, and an ag economist and a new agronomist. So I think that we'll have an opportunity to really move forward.
Can I ask Kate a question?
Sure.
How do you measure the soil microbiology activity?
I've been using nutrient cycling enzyme assays. So we have a couple different ways that we can do that, where we look at how we use substrates to kind of mimic what would be different components in the soil and look at the degradation of those. So enzymes that feed into the availability of nitrogen, phosphorus, sulfur, and carbon. Those are the nutrient cycling enzymes, but we're also able to dig deeper and to look at the genetic signature of the soil communities and then be able to kind of infer what they might be doing. So that's less of an activity measurement, but a way to kind of start to probe into what the communities might be doing. And with the nutrient cycling enzyme activity assays, it really reflects like a potential. So what is the maximum rate that we'd expect to see that? So we don't have good measurements on what they're doing in the soil at that time. But we are seeing, back to conversations on soil pH, seeing how the environment really shifts what these communities are able to do. So when you see changes in the soil pH, you have changes in the nutrient availability, but also in the community composition and the direct nutrient cycling activities. We see this shift a lot with the phosphatase activity, since there's two, an alkaline and an acid phosphatase. So you can kind of infer a little bit about the environment, but then there's also that impact. So with the work that Dawn's doing with the piolas, that's really interesting because you have the potential for some fumigation from the canola, if there's the isothiocyanates in the roots and that fumigation activity. But also with the legumes, you have the potential for increases in nitrogen, as that soil community is still being able to fix and cycle nitrogen, and the legumes have the rhizobium and the nitrogen fixing activity in there. So it's, I think, it would be a really neat complex dynamic between those two crops. So that was a long off-target answer. Sorry.
This is Ryan. I'm just going to step in real quick. We are now overtime, and in our kind of flexible time that we tacked on to the end. Just in case anybody needs to get anywhere, I would like to thank all the presenters, all the farmers who showed up, and everybody from industry who showed up, and then all the people behind this that helped make this research possible. I think we've got plenty of discussion. Oh, we've got one more closing poll. And then I think we'll be able to jump right back into the same discussion because I've been liking where it's going.
As you're answering the questions, I just want to echo Ryan's thank yous. This, wouldn't have been possible without a lot of effort behind the scenes. And we miss all the social aspects of gathering with you in person, but we value that we can use this technology and stretch ourselves to do some videos, which we probably should have been doing anyway. But we thank you for tolerating this technology as a way of sharing our research results with you. I might just say I've really enjoyed the discussion today. And in a field day setting where we're in smaller groups, this seems like an advantageous way to really be able to hear everybody's thoughts and interact. So thank you again for joining us today.
I'd like to add what Mary said. There are a lot of names on here. There are some names I don't recognize. Maybe you have a screen name that I don't recognize, and I know you from the field. But appreciate everybody being here. I hope those that haven't asked questions have got some of their questions answered, and look forward to working with everybody in any way we can in the future.
Thank you for your effort. I really enjoyed it today. Kept me interested.
I'd like to say on behalf of ARS that we really value input, both from other researchers, from WSU visitors, and certainly the farmers. Even if our research is long-term and we're doing something that takes 5 or 10 years, we still need and appreciate the input that we get every year by talking to you. Thank you.